Hey Quad folks, today I'm starting a little video collection series, I guess, remembering my friend Bev Gooch, who passed last June in 2025, and to give you just a little background about who Bev was, he came to Ampex Corporation in 1962, and he was there, well, I think he retired in 1989 or 90, and Ampex at that time hired him back as a consultant, which I believe he remained in that capacity until around 2001. So he was there at Ampex about 40 years, and he became one of the, I guess, the driving forces behind the scene in the head development after Fred Post had left in '67, I believe, and he had a lot to do with the development of the 1-inch Type A and the development of the Type C format later on, 1-inch. He was the inventor of the bidirectional tape head, the tape transport. Various other things that dealt with head construction, video and audio head, how they were manufactured over the years. And I believe he's credited with some 36 patents while he was at Ampex in head development. And so he was kind of one of the big brains at Ampex that you never really heard much about outside of the company or outside of the industry. I'd certainly never heard about him or heard that name until, just one of those accidental things, that happens in your life just once in a while. And I believe the first time that I had encountered him, I didn't know his name at the time. I had got back in this business in 2004 with the help of a friend, John Lewis. And I'd been in television, decades earlier, starting in the late 70s. And by then I had left television entirely in '03 and wasn't looking to get back into it in any way until '04, and my friend John Lewis at the time had brought it up, and so anyway, that led to our literally digging up a machine in the dark of night in Abingdon, Virginia, on one dark night. And that's a whole other adventure there. But anyway, that eventually, in those months afterwards, led me to a fellow in Bristol, Virginia, George Tipton, who had parts and pieces of a machine, that I was trying to put together at that time, an Ampex VR, which I eventually did, but, in the process of finding this stuff, one of the people I found was George up in Bristol. And later on, a year or so after our first meeting, George had a friend that I was acquainted with from back in the radio days. Bill, Bill Mountjoy was his name. And Bill was a character. He was into everything. And one of the things that he and George were into they were big Hamfest goers. They would go to all the Hamfests, and they would set up their table and, buy and sell and swap and trade, and, that was their thing that they did on weekends mainly, I think, back then. Well, George was, he knew what I was up to, and, we'd talk. So George, when he and Bill were on one of their trips to the Hamfests, far and wide, he started asking for me for 2-inch parts everywhere they went. Have you got any 2-inch stuff? You got any parts? And he kind of knew who to ask, from being, in that circle. And one day they were down at a Hamfest in Knoxville, Tennessee, at the Shrine there. Shrine Auditorium, I think. And one of the guys that walked up was Bev. And George had asked him, do you have any 2-inch stuff or anything 2-inch related for me, to help me out? And Bev said, yeah, I've got a few things, and didn't really say any more than that. I've got a couple things. Here's my phone number. And he gave us his number, which he gave to me later on. And George, I believe, said, here's this guy in Knoxville that says he's got a few things in his garage. Well, that sounded pretty good. I called the number, and I could never get through. For some reason or the other, I don't know if it just didn't connect, or United Intermountain had a loose wire somewhere. I could never get that number to work, when I dialed it. So I thought, well, maybe George wrote it down wrong. And I asked him about that, a few months later, the next time I saw him, I said, hey, this number don't work. So the next time he saw Bev in Knoxville, which was months later, maybe a year later, at one of the Hamfests, he asked him again for his phone number, and he got the same number. And, he brought it back to me. Well, that's the same number. Wonder why it don't work for me. It's just one of those mysterious things that we never found out an answer for. But, the main takeaway was I was never able to contact the guy, Bev. So I was still in the dark about anything. For several years, it went on, and so we got our machine built. with the help of John and George and Bill, I finally got enough parts together to build that first machine and get it running. And I did a job for the archive there in Knoxville, the East Tennessee, the East Tennessee History Center. A job for them that had some 2-inch stuff was part of it. And they gave a presentation one night there at the History Center. And I was invited to attend. And so they put me on the front row next to the president of the, the library and all this. And they had this, the lights went down and they screened this footage of various things, that they had collected over the past few years. And some of it was some of the stuff I did was the 2-inch quad holdings they had at the time, and so that all went well, and it was over and the lights came up and everybody was just kind of milling around there in the audience. It was kind of a thing. This would have been around 2005 or 2006, I believe, as near as I can remember. And so in the course of all this activity, I had been pointed out and introduced by the president lady there that night as one of the people doing some of the preservation work, of their screening. Well, after the thing was over and the lights came on and everybody was standing around talking, this older gentleman was making his way over toward me, and he said, "I just wanted to let you know that I thought your 2-inch work was outstanding." He says, "I couldn't see any color banding or anything in it. You did an excellent job." And he was just complimenting me all up and down about my 2-inch work, which was nice, but I said, well, he said, "I've got a few 2-inch things maybe you would like to be interested in." And I said, "Oh, sure, anything." And so we were, changing information, and what's your phone number? And it kind of rang a bell. I said, "Well, I think I've got your phone number, and I've tried to call you. Are you Bev Gooch?" He said, "Yeah, I'm Bev." And, he just said, "I've got a few things. Call me and, set up a time to visit, and you can come out and look at what I have, and maybe you might want some of it." It was just as simple as that. Now, he never said anything about working at Ampex 40 years or being the head guy of the head engineering department. He didn't, none of that. He just said, "I've got a few things. Here's my number." That was the kind of guy Bev was. He was the most unassuming, just a regular guy. He had absolutely no ego or any, importance, no airs about him at all. He was just a regular guy. And, that's kind of refreshing in itself. Being a TV veteran in this business more years than I care to remember. Usually it works the other way around. It's usually the person that has the least to say is usually the ones that talks the most. If you've been in television, you know what I'm talking about. It's usually the one that's least important. It's the one that's usually running their mouth all the time about how important they are. That was not Bev at all. He was just as down to earth as you could be, and a nice guy, in every way. And so, well, finally I got around about a year later, I think, to connecting again and going out for a visit one day, and I had no idea what I was walking into. This was the guy, the guru, if there ever was one. Now, Fred Post notwithstanding, but I didn't know Fred, so I didn't really have any connection there or any way to, but, that aside, Fred Post being, the prominent inventor that he was, aside from that, I didn't know Fred and had no way of, being able to connect with anyone, like that. Luckily, Bev was from Tennessee. He was from Nashville. When they retired, his wife worked, I believe she worked for the school system, California University school system. She was some kind of professional person as far as education, that sort of a thing. I don't know exactly what it was now. But anyway, when Bev retired, she was, I guess, retired by then too, and they decided, I guess they'd had enough of California, and the week after he retired, they packed up everything they owned and they moved back to Tennessee. Only this time, instead of settling in Nashville, where Bev was originally from, they settled in Knoxville, where his wife was from. She had grown up, I believe, in, well, I can't think of the name right now. It was just a little place outside of Knoxville, out in the country. And so they came back and settled in Knoxville when they retired. And I believe they had settled with their friends or maybe their relatives. They had bought a duplex in a gated community. And so Bev and Katie lived in one half, and then either their friends or their relatives lived in the other half. Well, they, at some point, their friends or relative had died, and that other half of their duplex was vacant. And so the idea occurred to them, Bev and Katie, to buy that other half of their duplex and knock a wall down and convert it into their den, I guess what you would call it. They had a lot of things that they had been storing that they had no place for, in their small, compact duplex. And so I guess their idea at the time was they would, since their friends had deceased, they would just buy their half, knock the wall down and convert it into a den of, and hang up some of their mementos, things that they had. And what Bev did with the back end, which was, a garage, he built a workshop. What else? And so that was the garage, that George was talking about, that he had been told at the Hamfest, I have a few things in my garage. It was his garage workshop, in their converted duplex. Well, okay, so I finally met the man, and it was interesting to say the least. To find someone that I could talk to, on that level. Now, at that time, I was just getting interested into this head rebuilding and making tips, and, I was right at the beginning of that, and really, what better person to become acquainted with than one of the guys, that had been there and done it, and had the patents on the wall to prove it, to back it up. If there was ever a source for information pertaining to that, it was Bev. So he had moved back to Tennessee and was right here, practically next door to me. I mean, that's, the planets had to be in alignment or something for that to happen. That was just luck of all luck, as far as my plight was to find the guy right, in my own neighborhood practically. And so that began, I guess, about 5 years of intensive study and learning. And I would study with Bev, go on extended visits, and under his tutelage, and learning from him all the details about how to make tips for video heads, how to assemble a video head, how to make the hardware necessary, to do that in order to, not just make a tip, but after you get them made, to assemble and, perform the alignment when you reassemble the head assembly, which is as important or maybe more important. After you do the work, you have to have a way to put all this stuff back together in alignment microscopically. So Bev was just good as gold in that department. He knew all that stuff. He'd been there. Some of it he had had a hand in the development of. So what better person or what better source to ask than somebody that, first-hand information. And at that time, that was really the thing that I was really lacking and desirous of, was information. I tried the front door approach, and well, at that time, the only front door left was a head tech out in California, and of course I'd gotten nowhere with them. They're not going to tell you anything, why would they? I mean, that's their, their business, their occupation, their source of income. So they have no really, they don't have any incentive to tell you what they're doing or how they're doing it. You know, that would not be of any benefit to them, you know, business-wise. So, of course, I never got anywhere going that route. And then the other way was through all of the secondhand, the armchair, the internet experts, you know, which, you know, a lot of that is hit and miss at best. You know, you can, you know, spend years chasing down that sort of information and get nowhere, you know, at the end of all of it. And so, yeah, it was really gave me the boost that I was looking for and needed, you know, for years. And you know, Bev did all that freely for me, you know, no charge. Here it is. So, in turn, what I've been doing and will continue to do as long as I'm able is to put as much of this information out that I have learned from Bev over the years, you know, about this subject, so that if it's something you want to learn more about or know more about, here it is, you know, and good on you, go do something with it. And at least, if nothing else, it's firsthand, and it's being preserved here in a public forum that anybody can have access to, you know. And so I'm really happy to be able to be in a position to share this with anybody that wants to know, because, you know, it was, you know, Bev was a special guy to me in all those years that I was privy to work with him and study under him and learn all this stuff. There's literally no way to do that anymore, I don't think, because he was the last guy that I knew that was still living. You know, that was one of the pioneers, you know, of all this stuff. And so here it is, and these are a collection of videos that I've made over the years of some of our conversations and interactions, things that I didn't want to forget. So I made videos of me and Bev in the moment, so I would have some reference to look back at later on after I done went home, you know. And a few of the late night conversations we'd have was, you know, that was kind of a thing. Bev would usually call me up late at night and we would talk for hours on the phone about this stuff, you know, and ideas or whatever I happened to be doing that week, you know, or some problem I was having with this or that, and we would talk about it. It's just, you know, you could never learn what a guy like Bev knew. It'd take you another lifetime to learn it, and then you still wouldn't know it all, you know. But I got what I could, you know, with the time that we had, our about 5 years, and documented it as good as I could. And so I hope you enjoy some of these videos, and, you know, if you like this type of thing or want to know more about it, I have numerous other videos of just me doing some of the work and, you know, trying to explain some of this stuff, you know, that I learned from Bev, the head man,
Well, yeah, that looks. Well, he has a nice.
I guess what we could do would be the best thing is compare it to a known good tip. You know, that's what I did at home. Is I looked at two of them under the same, you know, at once. One known good tip, and I compared it, and it looked about the same to me.
Yeah.
You know,
Well, this
comparing
measures.
it to other tips.
This measures. What was the gap supposed to be? 50?
50 was.
Well, it looks as if it is. That the bond is good, you know, in that area, and you have the strength. But he has a bond here, and he has a bond here, but he doesn't have an edge. He doesn't have a chamfer here. Those are just square. Yeah.
Okay. Was there any steps here? Could you tell that he had stepped this?
Step, I'm not.
Like to contour it like a rough, you know, we step down here, step down here. Was there any?
I'm going to draw this. You know, you see this tip, and then you see this thing is broken off here, and it kind of looks like that. And then down here, you'll see sort of something that looks you know, like sort of like that. And this is broken here, where it broke. So where it broke was here and here, but the bond didn't break.
Yeah.
Which is, yeah, why don't you have a seat here? Oh, thank you. This is your focus right there. So,
I see the bond line, glass.
When you see this fragment here, that's and there's a bottom fragment there too. So it looks as if to me that the bond is a pretty good bond.
Yeah, it didn't break there. It's in there.
With the ferrite.
And the middle part where it isn't bonded, it's just
Right.
it just fell away.
Right.
Yeah, but the top, whereas that's the business end, that's still in
Right.
one piece.
And the back is too. I
The
think.
back is still in one piece, and that's where it was bonded.
So
Well,
I
that's it, I guess.
think that will
If it was gonna break, it would have broke.
appears to be okay. Yeah.
Broke.
I don't want to. It's like testing matches, you know. That was a good one.
Well, yeah, I mean, if we could break all of these, but all we'd have was a bunch of broke kids.
It's clean. With no edge erosion. And the very back of it is the same way, but the middle has the edge erosion. And that's how you tell if it's bonded. But one of the ways you can tell if it's bonded.
You know, the back is bonded, and then it has like a little square that looks like it's full of glass.
Mm-hmm. Back in here.
Yeah. Is that
Right,
for
right.
strength? Or
Yeah.
Is that,
That's,
or is that the capillary?
well, that's for strength. He probably put his
Yeah.
rods in here and one in there. And, well, he could
And
he
then
could
the
throw it-
window is
he could
got-
throw it this way or that way.
The window has got a lot of glass in it
Mm-hmm.
below the. This gap here, up toward the top edge, it looks like there's nothing. I wonder why it looks different. Is there nothing in there?
What are you calling the top edge? That's your phase angle.
Oh, I wasn't
Okay.
standing close enough. It
Right.
says degrees.
Right.
It's out of focus back here.
So if you have a good inductor, the pure inductance 90-degree phase angle. So anything but your head, you can measure the phase angle, and then you can have to calculate the inductance. You know how to do that.
After I make these measurements, how do I know where I'm at? Is it good or bad, or what sort of range, or is there somewhere I can look this up? What sort of range should it fall within, I guess?
Well,
Would that be in the Ampex book?
well, the way you calculate it would be in the Ampex book. The Ampex book.
Well, I've got good
Hang on a
heads.
minute.
I could measure a good head.
You mind if I use the alcohol to clean this a little bit?
Not a bit. Just do whatever you need to do.
This won't, I'm sure this won't hurt the, I mean, because there's quite a bit of dirt on it. Well, with the edge damage and everything, it looks good. I mean, it doesn't seem to have any edge damage, which is very good. Very good. Half a megahertz.
Going half a megahertz.
Well, that's the maximum. Now, that generator goes on up, but I haven't used that.
Yeah.
generator in a long time, and so I don't know. Let's see, 1 kilohertz. Yeah, okay. It looks like it's working. All right, now let's see if we can. Let's move some of this stuff out of the way here. And I don't know. All right, let's check his, see if I can get on this with this clip lead. I don't know if I can or not. Maybe. Hmm. Well, there we go. Okay. Amazing, isn't science wonderful? Well, let's see now what that is going to. I'm have to get my calculator to work this out of the head. Okay, so the head is measuring. That's on the 10K. So the impedance is on the ×1 scale, so that's about 4.5, 4.5 somethings, and it's on the 1 scale. So the Z, the impedance, is 4.5 ohms, about 4.5 ohms. Okay, times 4.5 ohms, and the Q, that's the Q of the head is 80 degrees. That's the phase angle, and the Q, the Q of the head, which is a measure of the quality of the head, as the cosine of the phase angle. So, okay, so let's see what, and that one is, this one's a broken one here. Now, if we do another one, I don't know if it will show up at this frequency or not. We might have to go up to you see, that one's measuring 4 ohms there, so that's about the same. So this is not a good one to test, to find the cracks, really, because we've got so much other bulk material that it makes that one's 5. All right, that one's 5 ohms. Yeah, that's 6 ohms. Well, the red one is the highest inductance.
Is that the one with the scratch or the
Yeah,
crack?
yeah, that's the one that I
Well,
That's
and
it.
the one that was broke,
Broken.
it had the next highest, didn't it? I think.
4.5.
Yep. But then 4.5. But you see, and this measures 4. But your gap depth also has an effect on it, has a big effect on it, you know. And it measures almost 5, so I don't think this is too sensitive. I don't.
Well, and we don't know how far down the gap's
Well,
bottom is, because
See, this is-
we didn't glue it, so we don't know where that,
yeah,
if they're the same
And,
bottom or not.
measuring inductance of the head is not a very sensitive measurement because there is so much bulk material there that you're measuring the bulk material. You could probably knock a big hole in that head and it would almost measure the same.
What about the resonance? Well, how do you determine that?
Well, I can't get up. This won't
Oh, not high enough frequency.
go that high, right?
So it'd have to go to 10 or 0 to 10, or, well, actually it's about 6 to 10
Right.
megahertz is its range,
Well, we can
its operating range.
is to let's short that and see if it
Okay, you short the probe.
right and see if this should be, that's about right. This should be 90 degrees and this should be almost 0, which it is. Now let's see if we can get, let me put the standard on and see if we get just get a resistor of any that you know the value of, and
Is it like a non-inductive
right,
resistor, not wire wound?
right,
Just like a carbon?
carbon, right.
Okay.
Yeah, let me get- That's not right yet.
Okay.
Well, okay, now let's set this down to some low frequency. And this is going to be 0.5, that's a half a megahertz. And we should be well, let me just probe check. Okay, the probe's right. Okay, that's 100 ohms. All right, that's right. So that's all I probably, that's, okay. What you want to do first is to check your probe, and that should be, the phase angle ought to be 0, which it is, pretty close to 0, and that the magnitude ohms must be 100, and it is reasonably. Okay, now let's go up to your head operates around.
6 to 10 megahertz.
All right, now we got to go. Okay, that's 4.5, and then you dial it. Let's see. Well, let's just go to 10 maybe. This may be too high. Okay. I'm still right. See, this is 4.5 to 14, and I have it on 10 megahertz right there. It's been a long time since I've done this.
Okay.
Okay. Now I need to get over where you are down.
Okay, let me move out.
Now we need to take this out and out of here. Gee, I haven't used this instrument in a long time. And let's see, I don't, these leads might be too long. We'll see. At this frequency, they might be too long. Well, okay, that's measuring 8.8 really. I'm 100 scale, so it's 0.8. So that's 80 ohms. Let's see what that is. That's 80 ohms. About 80 ohms, and the phase angle is 90 degrees. Amazing. Okay. Phases information.
That's one of the ones marked as good.
Well, no, this one's, yes, that one is the one that's marked as good. It's kind of bouncing around a little bit. Let me see if I can go to. One that's marked bad, the one that he. But there's quite a bit of variable. Well, that is.
That the broken one?
Yeah, that's the one he marked broken.
Right.
And so this is, we'll call this one's a good one, maybe.
Yep.
Good one. And then the one that is the broken one is reading 60, 70 ohms. 70 ohms. And theta is not, but that wouldn't change very much because that's theta is 90. And this one's a bad one. Let's look at another.
The one that you thought
Yeah, which one did I do?
The red one here, isn't it? With the red mark on it?
No, I
Oh,
mean-
no, you did,
Which one did I do? I forgot.
I don't know.
Well, I'll go.
Okay, that's the one opposite the broken one.
Yeah. Okay, that's 80 ohms, and that must be it.
Yeah,
Okay,
but
that's-
I think that was,
Yeah,
yeah.
that's 80 ohms about.
Okay.
Then we're going round to the red tip.
The red mark, yeah.
Right. Do you see how to use this now? All right, and the red tip is, well, actually the red tip is 90, see, is 85 we'll call it. And the red tip, and that's theta is equal to 80. Sixty. 85, 85 degrees. So this one's the red one.
Mm-hmm.
I don't think you can tell very much by this, because you see, the reason for that is that you have such a bulk of ferrite.
How can you determine the resonant frequency of that coil?
Well, if it resonates, the okay, if it I don't think you can with this. It's not there. I'm gonna. Yeah, that's pretty good. Let's see if we've got a little alcohol here. See if I can just do it that way. You think these glass pockets are any stronger than those?
Well,
Oh yeah, that was pretty good.
I hope they are. I mean, they ought to be. It protects the gap,
Right.
you know, against pullouts and chipping from the edges.
Yeah, I was concerned about that with the 10 mil tips.
So what that is, that's actually a 10 mil. The thickness overall is 10 mils, but they that front piece for the gap has been
Make down to 5.
down to 5.
Well, this one looks very good. All of these are the same.
Well, these are, those are 5s. This is a 10
Okay.
laying there.
Let me put that one up there.
Yeah.
Picture at 7.5 mils or whatever it is. It's 7.5 mils, is it?
7, it was 7.5.
But still,
And then he took it down to about a 7.
that's good. I mean, that's
Well, and also,
excellent.
he's only got 3 wraps of wire on this thing.
So he's got 6 turns.
3. Oh, wait a minute. No, this is the 5 mil. No, that's another one. Yeah, he's got 4 on this one. No, he's
So-
got 5. There's 1, 2, 3, 4, 5.
Does that
Yeah.
count? The only thing that counts in turns is the ones that go through the window.
Yeah, see, here's the lead coming in.
Yeah.
There's 1, 2, 3,
So he's got
4, 5.
5 turns.
Yeah.
Yeah. Okay.
Yeah, so he's got 5
Well, that's about
turns.
standard. Yeah. Standard turn.
And he only did gentle lapping for 1 to 2 minutes.
Right. And he's getting a pretty good. He's getting a pretty good picture of 7.5.
Yeah, he sent me some more photos
7 mils?
of the waveform monitor and the picture monitor, and to position the tip under the shoe. And so, you know, this here will certainly, you know, let me do that, and then I can move in, and then this here if I need to,
Right.
you know. So I can jockey it around just about, and so that's, you know, that goes right under there because this is 5 and that's 11,
Right.
and
Yeah.
the tip is 10, so it drops right in that little hole. And I didn't know this till I got to playing around with it, but I had not realized that these tips are attracted by a magnet. You can lay this thing down and it won't move.
Right. Right.
And, you know, I thought, well, you can slide this thing around and it stays there.
Right. Yeah, that's good. So,
I think I'll set this magnet in this block right under, you know, where this is at. So when I drop the tip on there, this magnet's going to hold it, you know, right to it. Just like that.
Right.
And so if I set this into this block of aluminum, you know, right under that area where I'm going to be, you know, setting up and aligning and
Yeah.
moving, wherever I move it, it ought to just sit right there while I'm, you know.
Yeah. Sounds like a good idea.
So I got that, and then this piece here, you know, it
Mhm.
moves this way,
Right.
and I'm looking around waiting for something to come up on eBay, a smaller Unitron microscope that's illuminated,
Yeah, right.
that I can take apart and mount on a post here where I'm looking right there. And I got
Now
one.
you can, that one that I gave you,
Yeah.
that one, you can take out that barrel.
Yeah, well, I don't want to mess with that one. I want to get another one like it or smaller, and
You want a junky one,
I'll mess with it and tear it all up.
Right.
And I can make another. He said that's what they've been using
Okay.
when they were in the head
Yeah.
business.
Because we use Armstrong 82, but that was years ago. And Armstrong 82 was a white, it was a white, it was a filled epoxy.
You don't take much.
See, Ampex never did make ferrite heads for quads on a commercial basis because they,
That's an Ampex right there.
but that's an alpha cell too.
Right. And this is a spin physics
Right.
ferrite.
Right.
And that's what, you know,
Right.
modeled after is
Right.
that right there.
And that's good.
We used to use them at work and they lasted a
Oh,
long
yeah.
time. Spin physics.
I had a very good friend that I used to work with, and at Brush Electronics, and he went to spin physics. At that time, it was the old CEC. He went with CEC, and then when spin physics started up, he went with spin physics. And as far as I know, he's still alive. I hear from him every Christmas.
So still building heads?
No, oh no, he's a Brit.
I had to ask.
Yeah,
I had to ask.
he's from Scotland, but he lived in England. Yeah. Now,
Four
this,
outlets.
hmm?
I need 4 outlets to plug in.
Okay, how much?
Alright.
How much? Well, just a minute. I think we can. Okay, now here's, I think I can put the outlets right there. We can just plug this. Okay, and you should be on the air there.
That's the camera. Well, I started with this piece, you know, and I made this piece here, my buddy Henry made
Oh,
this, to mount, you know, the head drum
Yeah,
on,
right,
the
right.
one that we're
Right.
gonna adjust. And then, this is some of the metal out of your junk box that I used back in
Yeah,
December.
that's great.
And there was this little microscope
Uh-huh.
piece that I used. This piece I bought off of eBay because it had this
Yeah.
illuminator built
Uh-huh,
in it.
right. Yeah, that's a
And,
Unitron, yeah, that's,
And so the way you had described it, or the way I remembered it, is you said when they lined these things up, they had a large disc
right,
that had detents
Mhm.
in it.
right.
And so that's the idea of that. And so it was basically building a microscope mount to look
Right.
at that gap.
So I think it's very good. I think
And
it's super.
so let's see, get this thing all focused in here. See, 1 inch. And it ought to unscrew. There's a screw. There it is.
Type B wings, yeah.
Type B.
Let me get my eyeballs. Okay, well, now this is. Okay,
2 of those are video heads and 2 of them are race heads.
So now what do you?
Well, now
This is a
here,
type B. This is a helium thing.
that's a type B 1 inch. Here's the scan. That's the Bosch European
right.
system.
Right.
Now right here is the specifications for type B. And what I'm wanting to know is, this is the,
I don't have any experience with type B at all.
here's the modulating frequencies. And
He's a fairy.
if we were going to have some tips made, what would the gap length have to be for these modulating frequency range?
What's the tape speed?
Right here. Let's see, track length, track angle, overlap, pitch, track width, 160 micrometers.
Rotational speed is 150 RPS, multiplied that times 60. Let me get a calculator.
I got one right here.
It's moving right along.
150 revolutions.
Oh, here it is. Yeah, it's 900. They say it's 933. I say that's IPS. Well, that's revolutions per second. So, well, okay, yeah. Okay, yeah. We'll say about 1,000 hits. So what do you want to know?
Well, this is the modulating frequencies. Equalize almost 9 megahertz.
Okay.
And what would be a suitable gap length? Would our quad 50 micro inch gap lengths?
Well, let's see.
Would it be suitable for that?
Let's work out the wavelength.
You would want it to be half because that would cancel in the gap.
Well, yeah, the gap,
So we'd need to be like 3/4 of a wavelength as far as the gap is concerned.
well, you usually make it half. Lambda is equal to, what is it, speed over velocity, is that lambda? Yeah. Lambda is the wavelength, so let's see. I have to get my brains out. The wavelength is equal to velocity over frequency, all right. Now, so the velocity is, what did they say it is? It's 900 and something?
See,
It's 933, say 934, 934, and the frequency, what is the carrier?
well, the peak light was 8.9 megahertz.
Okay, 8.9 megahertz. Okay, so, so that's 934. Okay, that's not too bad. Is it 104 microinches? And see, this is 8.9 megahertz, so that's times 10 to the 6. And 934. And we'll say this is 9 megahertz, just to 9, 6 to 9. Well, it's just a tenth of a mil. Long wavelength. Yeah, your 50 microinch gap will be all right. Because the 50 microinch gap will give you 4 dB loss at this frequency.
Okay, the track width, 160, I guess that's micrometers.
Micrometers, yeah.
What is that in inches?
I thought you'd ask that.
Yeah.
Who knows? And these are the 6 mil tracks.
I brought some quad tips if you want to look at them under the microscope and look at the gaps versus the
Yeah. Yeah, that should work.
I could just take what I've got or what they make as a 10 mil quad tip and have him to lap it on down to 6. I wonder why would they put a little piece of, I guess that's a piece of brass or copper,
Here?
where they, on the tips, let's see. Let's see, which is which? Yeah, this one and this one are, the record layout, but these are the race heads. They got a little piece of metal here. Is that for balancers? I wonder why would they put a little piece of glue, a little piece of metal on? You reckon that's just for strength?
Now, where do you see it?
Right here.
Oh, that, okay. I'm
That
looking at
little
the wrong.
square piece of looks like metal glued on the ferrite. Is that for strength, or is that
Um,
is that for shielding? What would you be shielding that for? Must be for strength, I guess. Mechanical strength, would you think?
well, um, I want to take this with the other microscope out there
Okay.
and look at it, because I think do you have one of these machines?
No, I do not. I'm asking for a friend in England that does.
Oh,
And
okay.
Zdenek in Czechoslovakia, he has Bosch bees. And he said that he rebuilt one of his heads using Type C tips, I believe he said, which is
Yeah, well,
basically,
it's pretty close to Type C.
yeah.
Yeah.
And so the question was put to me by David in England. Can we, meaning Zdenek, rebuild a Type B head? And Zdenek said yes, he has, but he used Type C tips because that was before he knew me, and we had all these other tips.
Now, I don't think
So
these,
I thought the thing to do would be to look and see if one of these 10 mil quad tips could be lapped down if the gap was
Yeah.
the same.
I don't think that this is not a notched tip. It's just straight.
Yeah.
And so that piece and that, so that means that piece of ferrite is 6 mil thick. So they might have had that piece and back as a strength. But the piece on is a strength because
Yeah.
this would only be 6 mils here,
Mhm.
and so they might have wanted to make it stronger with it. But I want to look at it and see with other microscope.
That's the only thing I could come up with is maybe mechanical strength because it's not balance. I mean,
No.
how would you do it?
No.
You have balancing slugs on the thing, and that certainly you wouldn't want to do anyway. And I don't see why it would be shielding, because what would you be shielding it from? It wouldn't make a lot of difference, I don't think. You know, so I figure,
Right.
well, it must be for mechanical reasons, strengthening
And they
the,
connect this up to the slip ring. Wavelength is about 9 megahertz, and that's
quad is 10.
the wavelength is about a tenth of a mil. Quad would be a tenth of a mil too.
It goes to 10 megahertz.
Yeah.
I think Type C NTSC is also 10 megahertz, isn't it? But it's a different velocity, speed.
Yeah, it's like the wavelength of the Type C is a little bit shorter, but it would be okay. Yeah, I think that would work fine. To look at that piece of metal, whatever it is, under the microscope out there and see what it is. Yeah.
All right. Well, let's see. While we're microscoping, we might as well look at the big one too. That used for, you know. This fella sent me then. And it looks like a capsule full of metal shavings. Surely you don't eat those things. Like a pill, you know?
No, I wouldn't suggest that you,
Do you remember anything about what those things were for? It says Ampex. Part number, stainless steel flakes. The only thing I could think was, is it something to do with electron microscope or something
no,
like that?
well, you know, I don't know. It's stainless steel, so I presume it is not magnetic.
Weird stuff. Are they doing this before or after?
Well, now we did it when we were using it. We did it afterwards, but we had a special machine to do this.
That's an awful tiny thing. How would you ever hold the tip to grind it? I mean, that's a tiny
Well,
piece.
we used to take an abrasive. We did an abrasive manual. We did we had a form here that was the same shape as this, and then we used a lapping tape to lap this out after it was done. But
So the tape moved
yeah,
and then this pressed against it.
this was spooled
Okay.
of tape, and it would press against it.
And so this pressed against,
Yeah,
pressed the tape against the tip.
right.
What were the tips this size?
Yeah.
Well, I guess you'd have to have a little
But
hole
you can
for
do
it to sit in.
Now you can do this. The best way to do it is the way we made the glass filled heads, you know. We made the glass filled heads that you take a block and you cut the notches in the block, just like that, and then the other side would be like this. You see, this is your gap here, and this is your track width here. So you would make a block with, say, these 5 middle fingers or whatever the track width was. Okay? You with me?
I think so.
This is the blocks here, you see. So,
Okay.
and then we would fill these with glass. And then they'd be cut into the individual tips just like that.
I'm not seeing it. How do you get from that to that?
Well, the individual pips would come out of this block looking like
All right, now that's what we've got now. That's what we've got now.
now if you want that.
And what his problem is when he fills in here, it wants to run down and fill up the winding window.
Yeah. Well, the trick to that is you have to control the quantity of glass that you put in and the temperature very carefully. And that's the thing that,
Well, the hotter it gets, the more it'll
right.
easily run.
Right. So you just want the glass to be enough to flow in to the core. I mean the notched area, but not to flow into the winding window. And it's the quantity of glass that you use. You have to gauge the glass quantity very carefully. And we would put this, Mike, if you look at the tip on the side again, you'd have the gap down here, and you'd have the winding window here, and then you put the rods in here, and we would bond them upside down to where if you look at it this way, that they'd be upside down to where the flow would be here. So you have to control the temperature and the quantity of glass very carefully. Want to go? Well, let's try another one. I thought. Well, that is kind of dirty, but.
Oh yeah, that's an old head. That head came from Germany. But it was rebuilt out in California, back in the 80s or 70s.
Right. Well, I can't really tell with this magnifications. We could take it to the other microscope and see. Yeah, I was looking at it. Yeah, that's. That the notch is about as wide as the tip. So it's about a 10 mil. I would say if the tip is 10, then the notch is approximately at the top of the notch. At the top, the notch kind of. It's kind of a taper, which does that, and this is this is about 10 mils here. And this sort of tapers down, to radiuses down to that. So but if he can.
I'm gonna build me one of them. Try that.
And it's
I've got a transport. I've got a 440 transport.
I was running our machine ran it at 15 hips, but you can use it for 7.5 hips.
I think mine will go 15. It has a low-high
Okay.
speed. Yeah,
It's probably 7.5, 15 then.
I think it is.
Yeah.
Yeah.
So
And it's a rack mount, so I could mount it vertically,
yeah,
And that means the tip would be horizontal.
now see, we had a microscope on this.
So you can see what's
Yeah.
happening.
And the operator would look at the microscope, and it had a radical on it
Yeah.
that had, 2 lines to where they would put it between the 2 lines, and that would be the.
Well, there's my wintertime project. I'm going to build me one of them and try this. Because I got all these 10 mil tips. And if I just need 5 mil, that would get me there if it's strong enough, if it don't
Yeah.
pull out or have edge.
Now you have to have
or something
You have
like
to have a
that.
1/4 inch, with your machine, you have to have a 1/4 inch tape.
I can probably get that made by 3M.
And
And that was 6 micron.
we use the gray, which is the 6 micron, yeah.
Gray, that's right. I'm getting it.
Yeah.
While he's got that thing on, can you explain to me again the difference between alpha seal and alphanol? You told me once before,
Okay.
but I forgot it. He's videoing it now, so I won't forget it.
Well, alphanol is aluminum, iron, nickel. Alpha Sil is aluminum, iron, silicon.
What's their difference in their properties for recording beds?
The magnetic properties are very similar. The mechanical alpha seal is a harder material than alphanol. Alphanol can be stamped. Alpha seal, it cannot be stamped. And alphanol is made by rolling, like a steel mill.
Yeah.
And
That would be like where you mix it up in a big crucible and then
roll it out.
pour it out and
Yeah.
it rolls out.
Yeah,
Alphanol.
alphanol.
Alphanol. Yeah.
But alpha seal and alphanol is not as brittle as alpha seal. And alpha seal, it has to be cast.
Like an ingot and then cut and solid like we're doing here with the ferrite.
Right.
Well, is one of them wear more or less than the other?
The alpha seal has better wear properties.
As means it wears slower.
It'll wear longer with video heads, right? Right.
And the alphanol wears out quicker.
Yes.
Is it more granular, I guess, than alpha seal? Alphanol?
I don't know that. Well, alphanol is probably has smaller grains. Yeah.
Is there a way to visually determine just by looking at a tip if you're looking at alpha seal or alphanol? Is there any visual thing that you can determine which is which visually?
Well, yeah. Because alphanol has a sort of a more brownish look to it.
Like a golden brown
Yeah.
color?
Right.
Alpha seal, would that be more silvery looking?
Right.
Aluminum,
Right.
silvery. And the conductivity,
See,
I know alpha seal, you can measure it with an ohm meter. Is
Alpha
alphanol
seal
the same?
is aluminum. And this is silicon, I think. Yeah.
Are they, I know you can use an ohm meter and you can measure resistance. With alpha seal, is alphanol the same way? Is it conductive? You put an ohm meter
It's
on
about
it,
the
about
same.
the same.
Yeah. An ohm meter wouldn't be sensitive enough to tell the difference.
So basically, it's the color. That
Right.
would be the main thing
Yeah.
you would look for in determining. That seems flexible in alpha seal.
Right. And alphanol, they can be rolled. Okay. And that's how they make it. They
You know,
roll it. Alpha seal has to be cast.
the alphanol is more ductile,
Yeah.
more flexible than the alpha seal.
Right. But alphanol,
Alphanol can be stamped. Alpha seal cannot be stamped.
Right.
Is that right?
Right.
Yeah.
but alpha seal comes in the ingots, you know.
Yeah.
it has to be a cast material, it's not a roll material. But Hamilton Watch did, they had a huge metallurgical department, and they developed these materials for the use in their watches. And Alphanol, they made watch springs out of it. They either coil it and,
Yeah.
you know, they made Alpha Sil and thought it was maybe could be used in the same way, but as it
I wonder if Hamilton made any big clocks with springs in them made from alphanol.
I think they would mostly watches, wouldn't
I don't know.
they? But
It'd be
Alpha,
nice if they made some big
But they-
clocks and I could go get the springs and make tips out of the watch spring.
the Alpha Sil is, well, why would you want to do that?
Well, if they made the watch spring out of alphanol and it was 10 mils or more thick, I could just tear up a big clock and have a big long piece of alphanol to make tips out of.
But you'd have to bond it, you'd have to develop a way of bonding
But
it.
is that the same metal though? We're talking, it's the same metal, isn't it? The alphanol and a Hamilton watch
Well,
spring
I
are
don't-
the same as.
I don't know what they probably don't even make mechanical watches anymore.
No. Go to the antique store.
But Alphanol
That's it.
was used as watch springs, but Alpha Sil, as it turned out, it could not be used as watch springs. Yeah, because you don't lose contact. On this head, you might lose contact with the track to some extent. Now this was the earlier heads. Now, in the later Ampex heads, they used the metal. Thing.
Now that's a VPR2, and that's VPR8.
But this is not an Ampex head.
Well, I don't know who rebuilt that, but yeah, that's a VPR2 Ampex AST head.
Yeah,
Now,
right.
somebody probably have rebuilt that.
Right.
Yeah, it's a CMC. I
Right.
see it here now.
Right. Oh yeah.
This is an Ampex.
Right.
I'm pretty sure
That's an Ampex.
That's
I
a
knew that.
factory head.
I know
there.
that's an Ampex. Now the early,
Yeah, that says C. Says
the later-
CMC on it.
the later heads were made digital head. So, that,
Are these Type C? Are they 10 mil track width?
no, it's 5 mil track width.
Okay, so we need to use a 5 mil.
No, it's 6 mil. It's 6 mil. It's
6
type
mil.
C.
So we need to get
See
it
now
flat to
these were magnetic, like a speaker magnet.
Oh yeah, like a voice coil.
Yeah, right.
Yeah.
And they were parallel movement to where they would.
Mm-hmm.
But this was used when the digital head, the DST head. So, yeah.
Is there any advantage to doing that?
To doing what?
Well, you see how this tip is made?
Oh, no, not particularly.
It's just their, I guess, their
Well,
brand.
This was done on the Alpha Seal. The Alpha Seal heads looked like this, and this was just, it was done for strength, and this gives you more surface to glue on,
Oh, yeah.
which will give you more strength.
It gets real
And again-
wide. It's a lot wider at the
Right,
bottom.
right.
Yeah. Well, I noticed that when we
But
use
magnetically, there is no,
there's no real advantage or any difference. Well,
in fact, the ferrite heads are more, the ferrite core is more efficient.
yeah, I would think. No, get out of here and leave me
No,
alone.
that's
for a
all
while.
right. I'm having fun.
This is what Jack Bradshaw sent me. And this is what he's got. And those are glass brazing rods. And he measured a couple of his rods. He said they were consistent as 7.5 mil at one end and 8 mil at the other. But you know, our winding window is only about 6.5 mils. So I'm assuming we could not use any of those
I don't think you could.
for bonding the gap, but now the back end, you know, has a big notch where
Right.
we bonded at the back, so I don't know, that might
Why don't
be.
you ask the people?
His
in-
is smaller, his is
Okay.
like 3 mils.
Yeah. I think
The
I
fellow,
think these are pretty big here.
yeah, he said he measured they were 7.5 to
Yeah.
8 mils. And the lady down in Florida at Specialty Glass, they still have the formula for SP 2050, which is
Is that the glass?
yeah, I
that you're
think I
using?
sent you one of these emails.
Yeah, I think you did too. Yeah,
It's,
that you did.
let's see. Says if we've drawn this glass that small in the past, I don't believe we can at this time. We should be able to make 10 thousandths, 0.10 to 12 thousandths. We could try to go smaller in diameter, but I think this glass is very fragile and will break easily. The cost to make a run would be $1,200, and I would equate that to around 500 feet.
That ought to be enough.
Well, if they can do it, they're not sure they can. You know, the people that used to do it aren't there anymore. So it cost me $1,200 for them to find out.
Yeah. Well,
And-
do
and I
you really
reckon-
need that?
And Jack said, well, he said it somewhere not here, but Jack said he thought that I ought to just buy a rod, you know, a big fat rod of that stuff off of them
Mhm.
and find a local glass person. And he called it Pull It,
Mhm.
you know,
Yeah,
that can pull.
right.
And that's basically where they heat it up
And they,
and do that.
yeah,
You know, and
yeah,
it pulls out and it gets littler and littler
right.
the more they pull it.
Um,
And that, he said he thought that's what I could do a lot cheaper instead of you just buy, I guess, a billet or whatever they call it, a big
Yeah.
fat rod of the stuff. You know,
Yeah.
and it's,
well, now why do you want it?
well, so I won't run out, one thing. I mean, this stuff is, you can't just go buy it anymore. And even the people that
But I
used to
mean,
make it are
okay.
not sure they can make it.
Let me rephrase the question.
And their supply in England is running kind of low.
Okay,
And I'm looking around for, you know, a supply
So
in case
there-
they do run out.
so they, but now these rods, what size?
He measured these and he said were consistent at 7.5 mil to 8 mils from end to end. And he says that makes me think they were individually drawn, which I don't know, he's probably right.
What size, are you,
The window's about 6 mils wide, the lining window.
what size were your people in England using?
3
3 mil,
mil.
so that's about half of this.
And you know, the notch on the back for the back brazing is a big notch, and we could use that
Right,
for that, and that would save half of the glass, you know, or this little glass for the gap, and use this stuff on the back.
what,
If it's the same, you know, as far as
as far as the composition is concerned?
I guess that's the temperature, it says degrees, but I'm not sure what all of those little things mean. I wonder, I could probably send this to the lady in Florida. I don't know if she would tell me or not, since they're in the glass business, but
But this is the softening point here. The T
softening point.
This is the expansion coefficient here.
Well, so I guess those are standard terms. If I
And
looked
this is-
it up in glass terms, I could probably find
This is a
out
standard
what they all mean.
term. This is your temperature coefficient here. The expansion. And this is the softening point here.
So this was the part that has to match the ferrite.
Right,
Yeah.
right. And this is the, that's the softening here.
Well, all right. So if I give him that table, he'll know whether
This
it
is the
can
size
be
of the
used or
rod.
not.
This is the size here. Size. And this is the this is your temperature coefficient, and this is your softening point here. This. One of these is softening. I don't know what it is. One is the softening and one is the flow point, is the melting point. Let's see which one is what here. This is softening, T sub S, softening, and this is the think that this is the flow point here. And this is the, I think that this is coefficient. This, I'm not sure what this is.
Well, all right, I learned more than I knew. This was made in Russia in the 1970s. And he's had it all these years, and he also has a bonding furnace.
Is it what kind is it?
It's a vacuum bonding furnace used for dental type things. And Digital Equipment Corporation sent him all this stuff to do one job with, and that was all. And they didn't want it back. So he's had it all these years. I can get it pretty cheap. I wonder if
Just the height a little bit.
let's look at
And that's
the
looking at
bottom
this,
end.
at this, yeah, at this.
There it is. There.
Right. So you have a vertical slide on it too, don't you? Yeah.
Yeah, that's a piece I found in one of them boxes
Yeah.
that you had.
Good.
It's, you know.
Well, I think it's,
Now, how much tolerance? I mean, if we're looking at this one, how much left or right shift can you tolerate here, 90 to 90? Does it need to be half of this width, or right on the money, or within one gap width? What would be the tolerance? Or maybe a better way to ask it is,
well,
we know this is about 50 micro inches. How much shift would you see on the picture if I was maybe one gap length out of alignment, 90 to 90 from head to head? How much of
I
that?
don't think you'd see very much.
So if I can stay within this gap, getting the 90
Right.
to 90 aligned, then I should be
I think that should be
well
fine.
within
Well within the
tolerance.
tolerance.
So I wouldn't see much of a shift
Right. No,
over there.
no, you wouldn't.
Okay, well, that's what I was not
Yeah, that's-
sure about, was
that's great.
that. Now, here's something else that I haven't quite figured out, other than maybe this is not exactly flat, this surface of this piece here. We got the coplane here, so if
You have a height difference there, don't you?
yeah, so if I mark it with my finger and go to the next one. Now,
Yeah, that looks like.
if that's 10 mils, then that looks like it's maybe 1.5 or 2 mils
That looks like.
difference.
Right.
And now if you go on to the next one, see, they're the same. That's about the same, so I'll move my finger up here. So that one's there. And that one's there.
And that's about the same.
And then you get to this one. And it's a little low. I may have a low place, you know, or this may not be exactly,
Yeah.
and I was thinking maybe I could set up like a mic gauge here off
But
of
you need to
this
get
and see if I can, that might be throwing it off when I tighten it up.
is the wobble
Yeah.
in this. So you need to turn the face of this on the shaft that it's going to be mounted on.
So if I could take this piece and the shaft and put the shaft in the way,
Right. And
then I could get it true
make
on
a
the
cut,
end.
yeah. Just a
Okay.
light cut, and it would probably true it up. Because you could put your indicator on here, you see, and you could measure the run out.
Yeah, yeah.
It
So
has-
if I would just come off of this or off of this with an indicator,
Right.
and it would tell me if I had a high or a low spot
Yeah.
where it is. And then you're saying take the shaft out with
Well,
this on it.
If it'll,
Put that in
if
the
the shaft
way.
will come out easy, I don't know how that, I forgot how that shaft comes out. It probably doesn't come out that easy
No, it don't.
because the bearings are in there, they're probably preloaded bearings, and so they probably,
Well, I thought
Well,
about that. And
the thing to do is to, see, one of the things that you hold here, you bore in this, may be,
Yeah,
have some slop in it, okay? When you tighten this up,
turns it.
it's going to cock it
Yeah.
one way or the other. So, you might be able to get a shaft, mic this shaft, turn your shaft down to the same diameter as this shaft, and then
Using that shaft to put it on.
mount that on, and then turn it. That's not a very good way, but it's probably better than taking the spindle apart. Or that would be, but the run out is probably in this, you know. It's not very much.
I'm wondering if maybe I could they had a piece here that could move on that disc that actually had the detent in it. So you could adjust it.
Yeah.
So I need to add 4 of those. And
But you need to have something here, and then when you turn this 90 degrees, that you need to have something that would indicate that you had turned it 90 degrees. You see what I'm saying?
yeah.
So, does your,
Something else that I was looking at when I was
Does your
thinking about
machine is-
this, which I don't know if I need this now or not, but I was wondering, you know, once you get this calibrated and you put another drum on, you know, you've got
slot?
this.
Yeah.
And I was wondering if I was gonna be able to line that up every time. You know, you'd line it up, I guess you'd start with this one in the middle of its range,
Yeah.
and then, so ideally you'd start with number 1 in the middle, and then you'd center the gap in the display here.
Right.
And I was wondering if I could do that, you know, like this. I think I can. It's not as tedious as I thought it would be. See, and there's the gap. So if I had this screen laid out, you know, in a crosshair or a grid, that I would line that first gap up with the center line on
Right.
the screen.
Right.
And I think this might not be as big a deal as I thought it was going to be. You know, I could move it and get it online, and then tighten it down. Well, I moved it.
Right. Yeah.
Now I thought, well, if it is a kind of a deal, I found this little gizmo here.
Mhm.
The detent pawl that would engage this, I could put me a little, like a fulcrum or a pivot point here, and maybe put the thing that will engage it, or this, you know, a rod.
Yeah.
And this right here would allow me to move that
Mhm.
a little bit, you know. So if I bolted this down, I could zero it in right on the line
Mhm.
with this. You know, and since these would be fixed, then they would be 90, 90, 90, 90, and this would just zero my center, my
Mhm.
starting point.
Right.
And what would you use with this now? You know, one way you could use just a shaft, a round shaft, and like a point. But you know, you're going to get, if you drill a hole and you have a shaft through it, you're going to get
Yeah.
play, and you can't have that. I thought maybe like a be there every time you engage and disengage that
Right.
lever. That can't change, or you know, this won't mean nothing if it does. You know, it'll be off. So if I went and used this, that would kind of solve this problem, but I don't think that's going to be too big of a deal, you know, to get it zeroed
No, I don't.
on the first gap.
Right.
So if I didn't go with this, then what would I use as a detent pawl? Something that, I need something that's going to be the same spot every time I operate it. Can you remember what they were using at Ampex, or how they did it on their thing?
Well, we had something similar to this. I think that we had a ball. I think this was a cutout like a ball, and there was a ball that went in there too. Right.
Okay, so
And it would be-
it would be like,
And the ball
yeah,
would hit. I mean, the
well,
ball-
okay, so you need,
That would be the simplest thing to
so
do.
instead of me doing a V-notch in my piece that I mount here, I could just drill a hole, or not a hole, but you know, drill a little,
Yeah.
dimple the size of a ball bearing that I would use, and then use a ball bearing and a spring.
Mhm.
So that ball would fall in that hole
Right.
every time it went around. Well,
And-
that would probably
And
work.
then you could take, one of the things that you have to know is what's right, so you could,
Yeah, now I have a head that I can put on here
Okay,
that I
that's-
can use to
but I was
calibrate
gonna say-
this with.
yeah,
You know,
If you
I
have a
know the
head.
gaps are right on.
that if you have a head
Yeah.
that you know is accurate,
Yeah, I've
Then you
got
can-
that.
then you could just calibrate this, and then,
So I need to use a ball and a socket kind of an
you
arrangement there
know, more spring load.
with a spring load. Let's see, the ball.
Now, you should have you should have a spring load in let's see. I have want a ball?
I've got some, well, a
Okay.
bunch of them, but what keeps it from side play?
Let's see if well, you have to have the ball in a bore. Okay. You have to make you a bore that the ball goes into. See what I mean?
A hole that's
Yeah.
the size? Well, what about play?
Well-
What about that? What takes that away?
Well, just the accuracy of your hole versus the ball. You have to lock that hole in.
Well, I ain't good enough to do that,
Well,
but I see what you're saying.
um,
Well,
and they had all sorts of mechanical things. The gears and all of that precision stuff. And they might have the thing that,
well, is it possible to get a ball in a socket that has less play in it than the width of one of these gaps? Because it would have to be less than that. Because if it was more than a gap width, it'd be off. You know, the ball and the play with the socket.
well,
It's probably doable because this thing moves quite a bit when this moves a little bit. So you gotta,
but this is a lot of moment, see. You have a disc, what's the diameter of this disc?
I believe that's 12 and a half
Yeah.
inches.
And that's only, that's only 2 inches, so it's a big disc. So this you can move a lot,
Yeah, so it's got more tolerance.
right?
there. Well, I see that. Okay, so
So
even if it didn't fit all that good, it may not be enough to throw this out.
right, well, your ball is going. The only thing that requires is that your ball doesn't move within its holder. See, because you can put a V notch in this for the ball to index into, and it'll index in the V all the time.
Mm-hmm.
This is an angle plate. Would you have use for that?
Possibly. I don't know.
Well, I think that if you use, as we were saying here, if you use the ball there in some way to position that ball, and I think that you could make a ring fit on the ball in a bore, would probably work okay.
Yeah.
Because what's the diameter of this disc?
I think that's 12 and a half inches.
Okay, and this is 2 inches about,
Yeah.
so that's about 6 to 1, something like that, right? 6 to 1, whatever that is. Oh, I think it's getting,
Yeah,
super near, Larry. I think it's really great, really great.
Let's see, I'm gonna take this piece of paper with
Oh, yeah, you can take the page. And now I have something, I have some pieces of aluminum. Are you interested in those? I thought maybe, but if you weren't, your machinist might be